Dear audience, let me introduce myself. My name is Michael Orlovsky. I am a fifth-year pilot cadet of Ulyanovsk Institute of Civil Aviation, and I'm here to present you this lecture on aviation topics, which I was lucky to give during my master's program in La Sapienza University of Rome, Italy, as well as in Samara State Aerospace University, and I would like to share this experience with you. So, as you can see on the screen, our topic today, the investigation of a case, the accident of flight TK981 of Turkish Airlines. And I would like to divide this lecture into three parts. The first one is the overview of the accident and the flight data. The second one is the mistakes made. And in this part, I would like to consider two different safety management approaches: the reasons model and the dirty dozen concept. They are intended to eliminate human factor and operational mistakes. And they are nowadays used in almost all of the aviation and air crash investigations. And of course, the lessons learned and conclusions. So let's get started. Let's start with a quick review of the accident that shocked the aviation community. And here is given the flight data. As we can see, on the 3rd of March in 1974, Turkish Airlines flight TK981 took off out of Paris International Airport, and it experienced, this particular type of aircraft experienced a severe decompression, explosive decompression to be more exact. The differential pressure between the passenger and cargo compartments collapsed the floor and severed the hydraulic lines that ran within the floor. So finally the aircraft crashed and 346 passengers were killed. And this story was a culmination of a chain of hushing up and patching up. Let me play you a short video in order to visualize the situation.
Just after 12:30 in the afternoon, THY Flight 981 lifts off into the skies above Paris. London is less than an hour away.
Race control, this is Tango Hotel Yankee 981. We're at 60, requesting clearance to flight level 230.
Tango Hotel Yankee 981, you are cleared to flight level 230.
981, roger.
As it flies away from the airport, the DC-10 continues to gain altitude. 2,700 meters, 3,000 meters, 3,300 meters. The huge jet shudders and banks to the left.
The cabin blew out! Are you sure?
Just 16 seconds after the start of the crisis, the crew struggles to save their crippled jet. The nose is pitching down, the plane picking up speed.
Bring it up! I can't bring it up! She doesn't respond!
Passengers at the back of the plane witness a horrifying scene. 2 rows of seats have simply disappeared. Through a huge hole in the floor, passengers can see the sky over France.
7,000 feet! Hydraulics! We've lost it!
The crew discovers that they have no hydraulic power with which to control the plane. Without it, they can't move their rudder or elevators. Even without its most basic controls, the plane begins to level out. But it's fallen too far.
Looks like we're going to hit the ground! Speed!
The DC-10 is traveling almost 800 kilometers an hour.
So here we can see the scale model of the impact of the aircraft at the forest at a manual force and Paris. In these slides you can see the conditions of the crash and the bulk cargo door which burst open. And in these pictures you can see what happens if you violate the primary aviation regulations. And to reveal the tangle of errors that led to the disaster, let's turn to the Swiss cheese model proposed by the British psychologist James Reason in 1990. And this model helps to visualize how various contributory factors come together to culminate in an accident, and it is also known as cumulative effect. The slices of Swiss cheese in this picture, they illustrate the protection layers of the system and its defenses, but while the holes present deficiencies. And in the previous slide, we could see that they can be subdivided into latent and active errors. And also we can point out here the dirty dozen model. We'll talk about it a bit further. And okay, the dirty dozen model itself, it was invented by the special programs coordinator of Transport Canada, Gordon DuPont, in 1993, and it reflects the main 12 human errors and mistakes during any kind of operation. And in our case, we can draw your attention to the four main problems: lack of communication, lack of sufficient knowledge, operating pressure, and of course non-precise standards and norms. And now I want to draw your attention to the different kinds of errors. Those are latent and active errors, and latent errors are that don't have immediate impact on the system and on the well-being of the system. These errors are connected with the operation work of such people as designers, constructors, manufacturers, top managers, and procedures writers, of course. These problems lay dormant in the system until they combine with active errors or appropriate triggers to culminate in an accident, to make an accident. And active errors, of course, that errors that don't have an immediate effect on the system. They are usually made by such people as pilots or maintenance operators. So this means with those people who are in direct contact with the hardware. And James Reason subdivides these active errors into different levels, and we will talk about only four levels of our case. It is organizational influences, unsafe supervision, preconditions for unsafe acts, and the unsafe acts themselves. This crash definitely wasn't caused by an isolated event. It was a chain of events that culminated with organizational management and human errors. And the first latent error is that there were serious design flaws in the construction of the cargo door of the McDonnell Douglas DC-1010. In this picture we can see the difference between the correct latching and incorrect latching. On the right side, we'll see that the hook is into the locking position, same as in case of correct latching, but the leg here still has a torque in it, and it is not in the stop position. As a result, we have incomplete extension of the actuator's shaft, and the engagement of locking pins is still impossible, which leads to that the other center is not achieved, and the whole system is still reversible, so it can unlock. Latent error number 2. The company that manufactured the cargo door for McDonnell Douglas warned that the lack of bands in the floor and the design of the door can eventually lead to a disaster, but McDonnell Douglas did nothing about it, and American Airlines lost their cargo door in flight 2 years before this accident. So FAA issued some regulations to make modifications to this cargo door, and let me show you, play this short video about this accident.
There were early signs, however, that the safety of the plane itself might be less than perfect. In June 1972, this American Airlines DC-10 lost a rear cargo door over Ontario in Canada. The passenger cabin floor collapsed after the sudden loss in pressure, severing most of the hydraulic control cables. Only the fact that the aircraft was lightly loaded, combined with the skill of the pilot, enabled the plane to land safely with the 67 people aboard.
The FAA compromised their position as an aviation authority. After American Airlines incident, they prepared airworthiness directives requiring all DC-10s to be grounded until the modifications were made. But the president of McDonnell Douglas managed to persuade the head of the FAA to downgrade the urgency, as he was afraid that this will affect the sales of the aircraft. And unfortunately, FAA gave in. So they issued service bulletins instead of airworthiness directives, and the difference is fundamental. The first one is just an invitation to do something, but the second one is a mandatory document to follow. And it's easy to state that most of the crashes and aviation incidents and accidents have almost the same reason in all the cases. It's money. All those violations and mistakes are provoked by the rush of money savings and gaining profits. Latent error number 4. Turkish Airlines didn't fix the fatigue problem with the locking pins, and this could reflect some possible organizational problems with Turkish Airlines, possibly with feedback and reporting system. Here we can see the lock pin of the cargo door, which was affected by the fatigue. And the last but not least, latent error number 5, baggage handler, inadequate training. Algerian handler was asked to close the door, and he did so. He knew how to close the door, but he didn't know how to use the window which McDonnell Douglas added to inspect the locking pins. And he spoke neither English to understand these caution signs, neither nor Turkish to communicate with the crew. So the problem is inadequate training, of course. If the baggage handler had been taught how to inspect the locking pins, he could have known that something was wrong at the moment. And now we have the full view of the accident, and let me play another video to sum up the information.
But McDonnell Douglas designed the cargo door on the DC-10 to open outward. That decision was made to increase the amount of storage space on the plane. When it's closed, hooks on the DC-10's door grab hold of a bar on the plane's doorframe. To make sure it's closed, baggage handlers push down on a lever, which drives locking pins through the hooks, which hold them in place. Investigators make a frightening discovery. It's possible to close the lever on the outside of the door, even if the hooks and locking pins are not in the closed position. They also suggested that vents be put into the floors of all DC-10s. This would rapidly allow the pressurized cabin air to equalize without collapsing the floor. The company itself could be at stake. March the 3rd, 1974. A perfect spring-like day in Paris. It's been almost 2 years since a DC-10 came close to crashing near Windsor, Ontario. Now more than 50 of the new planes are flying around the world. One of them, Plane 29, is owned by Turkish Airlines. Normally, the last leg of this trip from Turkey to England wouldn't be very crowded. But today, the DC-10 is filling up fast. People are squeezing into seats throughout the plane. A strike at a British airline has passengers scrambling for any flight back to London. Wendy Wheel is one of many last-minute additions to the flight. A model, she's returning home after a shoot in Spain.
We'd been married for 18 months, and we were about to start a family. I believe the secret of her success for modelling was not just that she was a very attractive girl and good model material, but she was generally liked by all the photographers because she had such a pleasing, lovely, light personality.
With all the new passengers boarding, the flight is a little behind schedule. And it's not only the crew who are waiting. At the back of the plane is baggage handler Mohammed Mahmoudi. With all the new passengers, he's not sure if there are any more bags to load.
C'est tout. Bien, j'ai l'affaire.
Not expecting any other luggage, Mahmoudi locks the rear cargo door. The DC-10 is set to go. Just after 12:30 in the afternoon, THY Flight 981 lifts off.
Now we know what happens later. Okay, now the lessons learned. We can identify the problems that might have led to the disaster, and now we know that it's not enough to just focus on the accident itself. All contributory factors must be taken into account, and on each stage of the way it passed from the design of the aircraft up to the moment when the DC-10 crashed, there was a potential for errors. And as making errors is a part of human nature, so therefore no system can be perfect. And after the crash, McDonnell Douglas finally carried out the modifications to the cargo door, and the FAA issued airworthiness directives requiring all DC-10s to be grounded until the modifications were made. Finally, safety should come before benefits and profits in high reliability industries. Thank you very much for your attention, and if you have any questions, feel free to ask them. And here you can see the references of this work, where you can find more data on this case. Thank you. When I was giving this lecture during my summer school in Samara State Aerospace University, Peter Barrington, the head professor of Kingston University of Aviation Engineering, asked me a very good question on this topic. So that's why I decided to add it to this current presentation.
Okay, I have another hard one.
Okay.
You say safety should come before profits, but you can always add another inspection, you can always add more training, you can always add more costs. How do you decide when you've done enough?
By the statistics, we can see it as...
Because these major accidents don't happen very often. So if you were managing a safety process, you have to decide, is it good enough? What criteria do you use?
This is not my specified field of education, right? Because we have guys here from safety management, and they can answer the...
Well, but even as a pilot, you can always add more training. You can always add, flying less hours so you're less fatigued. But how do you decide? Because in the end, aviation is still a business.
Yeah, sure.
It's a business that has to pay, otherwise you don't fly. So how do you make that decision?
For example, we here in Russia, what I personally know, for years we had management in aviation institutions, for example, in my institute as well, and later on they found out that I have to add that airports and aerodromes were headed by the managers for a long period of time, and after a while they found out that in all those regions and areas the main issue is to save some money, to just the economy, because it's not their fault. That's what they were taught for. That's what they were studied to do, just to have some savings. And after a while in Russia, they started to give those really high positions in aviation industry only to ex-pilots, ex-engineers, ex-air traffic controllers, because they know that safety comes first. That's my point. Any others? Okay, then thank you once again for listening to me.